Suppose we have this number x and it's 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the 5 and so on. So it's 1 over 2 to the power of a prime number, and we're adding that up over all the primes. Is this number x rational? That's the question we're going to be answering today. Well, firstly, let's appreciate that x is indeed a finite number. This thing here is less than the geometric series 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the 4 and so on. And this just turns out to be a half. So x is definitely finite, it's positive and less than a half. Is it a rational number? The answer is no. And the way we're going to prove it is by looking at this number in base 2, so in binary. But before we do that, let's just appreciate a fact. I'm not going to prove this fact, maybe I'll encourage you to try and prove it yourself. If you take any number and you look at it in any base you want, that number is going to be rational if and only if its digits are eventually periodic. So let me just repeat that. I'm claiming, or I'm just stating this as a fact. Any number, any real number is rational if and only if, whenever you write it in whatever base you want, its digits are eventually periodic. So for example, if we just work base 10, if I look at the number, I don't know, 126 over 99, this number here is 1.27272727, blah, blah, blah. And if I maybe put an extra zero on the end, that would shift the decimal point here, and this would be 0.1272727, blah, blah, blah. Notice that it's not necessarily periodic straight away, but eventually the digits become periodic. So 272727, and this works in any base you want. So how do I know that this number here is not rational? Well, it's not, or its digits are not going to be periodic in base 2 or in binary. Well, what is this number in base 2? Well, it's going to be 0 points. We're going to have 0 here, then 1, because this, remember, is 2 to the minus 2. Then we're going to have 0, oh, sorry, no, we're going to have 1 there, because that's 2 to the minus 3, 0, then 1 for 5, 0 for 6, 1 for 7, and so on. And we're going to have a bunch of zeros and only going to have ones when there's a prime number in that kind of position. So this is the first position, this is the second, and so on. Okay, so why is this thing never periodic, or will never eventually be periodic? Two reasons. Firstly, there's infinitely many primes. So that means in this sequence here, there are going to be infinitely many ones. However, on the flip side, if you choose any number, any big number, 1,000,000, 2,000,000, whatever you want, eventually there will be a gap or a sequence of 1,000,000 zeros in this number. So in other words, if you choose your favorite big number, let's say 1,000,000, I can find, or there exists, a sequence of 1,000,000 consecutive positive integers, none of which are prime. And I've actually proved this on the channel before, but I'll quickly prove it again. Let's say your favorite number is n, and we're trying to prove that there is a sequence of n positive integers, none of which are prime. What we're going to do is consider the number n plus 1 factorial plus 2, n plus 1 factorial plus 3, n plus 1 factorial plus 4, and so on, all the way down to n plus 1 factorial plus n plus 1. Now, this is definitely a set of consecutive integers, and there's precisely n of them, so n consecutive integers. Now, this first one, that can't be prime because it's clearly a multiple of 2, because that's a multiple of 2, and n plus 1 factorial is also a multiple of 2. This guy here can't be prime because that's a multiple of 3, and that is also a multiple of 3. And similarly, n plus 1 factorial is going to be a multiple of 4, and so is the plus 4, so this can be a multiple of 4, and so on. I can keep going down this list. All of these numbers I can easily show has at least one factor bigger than 1 that's less than itself, and so therefore cannot be prime. And so that proves that this number x here is irrational, with quite a cool proof. We didn't have to do contradiction or anything like that. I hope you have enjoyed this video. Thanks so much for watching. I'll catch you in the next one. Have a great day.